Welcome to the Prompt Index, the podcast where we unpack cutting-edge AI research and translate it into take-home insights you can actually use. Today, we're diving into engineering of hallucination in generative AI. It's not a bug, it's a feature by Fingscheidt, Blumenberg, and Möller. The core question, can we harness hallucination, often seen as a flaw, in a productive way? At the heart of this work is a shift in mindset. Generative AI isn't just about being truthful in the strict sense. It's about usefulness for a given task. The authors show that hallucination can be steered via probability engineering in two big families: large language models and video generation systems. Let's start with LLMs. An LLM is an autoregressive decoder that predicts the next token from a probabilistic distribution. In practice, inference uses softmax with a temperature parameter to shape that distribution, not a simple argmax. Then we do sampling, top K, keeping the top K tokens, top P, keeping enough tokens to cover a probability mass P, and min P, forcing a minimum probability floor. Temperature warms the distribution, more fantasy; cooling it tightens the spread, more truthfulness, but still not a guaranteed match to reality, because the model purposefully samples among plausible tokens rather than choosing the single most probable one. The authors illustrate with a Braunschweig River question. As you nudge these hyperparameters, the model can drift from a correct ochre to near misses, like Oster, and even reflect on its own misstatements as the dialogue evolves. A striking point: the model's outputs effectively become a self-reflecting loop, since the sampled tokens are appended to the prompt, influencing subsequent predictions. This autoregressive loop can produce corrections or paradoxical statements, depending on how you tune the sampling. The paper also extends these ideas to Gaia 1, a generative video model. Here, top K sampling dramatically changes the future frames. With K equals 1, frames freeze. With moderate K, you get coherent yet plausible motion. With higher K, you see more fantastical elements: cars turning, pedestrians on horseback, even impossible scenes. The authors note a sweet spot around modest top K values where useful hallucination expands the test space without collapsing into nonsense. Limitations aside, the takeaway is clear. Hallucination is not inherently a bug. When you tune the right hyperparameters and possibly pair them with post-training, reasoning, or self-verification techniques, the creative, exploratory power of AI can be harnessed for practical tasks and safety testing alike. Thanks for listening. If you found this valuable, please like and subscribe to our channel. To advance your AI knowledge further, check out our free resources at the Prompt Index. You'll find the link in the description below. Until next time.